Okay, so I wanted to go over the homework that was assigned this week. And the first page here is simply identifying the location of fractions on a number line. So for instance, if we look at 3, for example, the distance between 0 and 1 here has been divided into 1, 2, 3, 4, 5, 6 equally spaced positions here. And we need to identify the location of 4/6. So if we understand that each of these tick marks shows a sixth, we can label those sixths and we can see the location of 4/6 would be located here. Now keep in mind here that 6/6 is equal to 1, and that's an important concept for kids to understand. So for example number 4 wants us to find the location of 2 halves, and since the distance between 0 and 1 here has been divided into 2 equal sections, this first tick mark is 1/2, and then 2 halves is equal to 1. And the rest of the problems on this first page are very similar. The only difference with the bottom questions here is 8 and 10 deal with improper fractions, so when the numerator is larger than the denominator. So this back page here is dealing with fraction concepts that are a part of Unit 2. And this unit is about recognizing that fractions are closely related to division. In fact, fractions and division expressions can really be thought of as explaining the same relationship between the same numbers. So the directions here ask students to draw a diagram or a picture to find the quotient. Now the quotient is simply the answer to a division problem. So we have 1 divided by 3 here. So this question does not ask students to put 1 divided by 3 into a calculator to get a decimal readout. Instead, we need to draw a diagram or a picture to show what 1 divided by 3 really means, and then we can use that diagram and picture to find the quotient. So in number 1 here, we're dividing 1 whole by 3. So we're going to have 1 whole separated into 3 equal parts. So I can represent 1 whole with this picture here. So it's just a rectangle. We can assume the entire rectangle is equal to 1 whole. So now I would divide this 1 whole into 3 equal pieces. And of course these aren't equal per se, just because I can't draw perfectly freehand here, but it helps kids to understand that we're taking 1 whole and then we're dividing it into 3 equal pieces. So the size of each of these pieces would be 1/3, because it would take 3/3 to make up 1 whole. So the quotient of 1 divided by 3 would be 1/3. And hopefully students understand too that we can go in reverse here and identify that 1/3 as a fraction is also equal to 1 divided by 3. So skipping down to 3 here, we're starting out with 2 wholes. So instead of 1 whole, we now have 2 wholes. So I'm going to draw 2 wholes. And I need to divide each of these wholes into 3 parts, 3 equal parts. And of course, we're going to need to use some imagination here and pretend that I can draw two perfectly equal wholes divided into equal sections. Okay, so I have two wholes. I've divided each whole into three parts. And one way, again, to help us understand the quotient here is to imagine a situation. So if we attach a context to 2 divided by 3, it makes the quotient a little easier to understand. So we could imagine that there are two sandwiches. And we've been talking about sandwiches a lot in class. So we have two sandwiches. And let's say we divide those two sandwiches equally among 3 friends. Well, if I imagine that one friend will receive a shaded part from both of these sandwiches, we can see that they're going to receive 1/3 of a sandwich from the first sandwich and another third from the second sandwich. And so altogether, they would receive 2/3 of a sandwich, which is why 2 divided by 3 is equal to 2/3. So a picture and a diagram helps us. And then when you pair the diagram with a story or a context to understand what's happening when we divide 2 by 3, it's much easier to see that 2 divided by 3 is equal to 2/3. So the next question asks us to write a story problem about people sharing sandwiches. And once we've written that story context, then we determine what fraction of a sandwich each person would receive. So since I'm dividing one whole by 4 here, we can assume that there's one sandwich. And since we're dividing that whole by 4, we can say the sandwich is being shared equally by 4 people. And so the story or the context can be that simple. And but we need to figure out what fraction of a sandwich each person would receive. So again, if we pretend that this rectangle here is one sandwich, and then we divide this rectangle into 4 equal pieces, we can see that one person would receive one of these 4 equal pieces, which is equivalent to 1/4 of the sandwich. So 1 divided by 4 then would be 1/4. And so each person in this problem here would receive 1/4 of the whole sandwich. Okay, so the last section here asks students to write the division expression each of these fractions represents. So students have been working on drawing diagrams in class, as well as connecting stories and context to division problems and fractions. So the connection that they're making is that every fraction can be expressed as a related division expression. So 2/3 is equivalent to the whole number 2 being divided by 3. And we worked on a similar situation here where we divided 2 by 3 using diagrams, and we saw that 2 divided by 3 is equivalent to 2/3. So 2/3 then would be equivalent to 2 divided by 3. Many times students like to use this convention here, where there's the division sign kind of looks like a house. And so a lot of times students will assume that the larger of the two numbers in a division expression is going to be situated in this quote-unquote house. But this is incorrect. This here does not match this. We would read this expression as 3 divided by 2, not 2 divided by 3. So if students wanted to use this convention here, they would actually put the number being divided, or the dividend, inside of this house-like symbol, and then the divisor, or the number of groups that we're dividing this number into, would go on the outside here. So again, students are going to recognize that the numerator of each fraction represents the number that's being divided, or the dividend. And then this denominator here will represent the number of groups the numerator will be split into. Or, in other words, the denominator will become the divisor when the fraction is written as a division expression. So, I hope that gives some clarity in terms of what students are expected to do on this page, and as well as this page here. Now, the last 2 pages of the homework are finding the volume of composite figures, which is a review from our last unit. And these, the answers for these have been sent in a PDF file along with the homework itself through a Remind, and then there are videos available on my channel that go over the steps required to find the volume of these types of figures. So I hope this helps.